How Mars was in the past. Based on scientific evidence gathered by space probes, rovers, and telescopes, scientists believe that Mars was a much different place in the past than it is today. Early Mars had a much thicker atmosphere. The idea that early Mars had a much thicker atmosphere than it does today is supported by various lines of evidence, including the composition of Martian meteorites, the observed characteristics of the planet's surface features, and data from orbiting spacecraft. One of the key pieces of evidence for a thicker atmosphere in Mars' past comes from the study of Martian meteorites that have fallen to Earth. These meteorites contain gases trapped inside that provide clues about the composition of the Martian atmosphere in the past. These gases include nitrogen, argon, and carbon dioxide, among others. Analysis of these gases suggests that the Martian atmosphere was once much thicker than it is today. Another line of evidence comes from the characteristics of Martian surface features. For example, the presence of ancient riverbeds, lakebeds, and other features suggest that liquid water once flowed on the Martian surface. To support liquid water, Mars would have needed a thicker atmosphere to raise the surface temperature and increase the atmospheric pressure. A thicker atmosphere would have also helped to protect the planet's surface from the harsh solar wind. Data from orbiting spacecraft, such as NASA's Mars Atmosphere and Volatile Evolution (MAVEN) mission, also support the idea of a thicker atmosphere in Mars' past. MAVEN has detected remnants of a magnetic field on Mars, which would have helped protect the planet's atmosphere from being stripped away by the solar wind. However, this magnetic field is now very weak, and the Martian atmosphere is very thin, mostly composed of carbon dioxide. Overall, the evidence suggests that early Mars had a much thicker atmosphere than it does today, which would have allowed liquid water to flow on its surface and potentially supported a more Earth-like climate. However, the exact composition and density of the Martian atmosphere in the past remain topics of ongoing research and debate among scientists. Mars had liquid water on its surface. There is strong evidence to suggest that Mars had liquid water on its surface in the past, and that it may still have liquid water in some form today. Here are some of the key details. Evidence of ancient water. Mars is covered in geological features that suggest liquid water once flowed on its surface, such as dried-up riverbeds, deltas, and lakebeds. These features have been observed by various spacecraft, including the Mars Reconnaissance Orbiter, MRO, which has identified a number of sites where liquid water may have existed in the past. Recurring slope lineae, RSL. These are dark streaks that appear on some steep slopes on Mars, particularly in equatorial and mid-latitude regions. Scientists believe that RSL may be caused by the seasonal flow of briny water, as they appear to fade away during colder seasons. However, the exact mechanism behind RSL formation is still not fully understood. Subsurface ice. Mars has large amounts of water ice stored in its polar ice caps and in the subsurface, which have been detected by spacecraft such as the MRO and Mars Odyssey. In some regions, the subsurface ice may be relatively close to the surface, and could potentially be accessed by future human explorers. Martian meteorites. Some meteorites from Mars that have fallen to Earth contain tiny structures that may be evidence of past microbial life. The structures are thought to have formed in water-rich environments, adding further evidence to the possibility of liquid water on Mars. Overall, the evidence suggests that Mars had liquid water on its surface in the past, and that some forms of liquid water may still exist on the planet today. This makes Mars an important target for future exploration and the search for signs of past or present life on the red planet. Mars had a magnetic field. Mars currently has a weak magnetic field, but there is evidence to suggest that it had a much stronger magnetic field in the past. Here are some key details. How magnetic fields work. Magnetic fields are generated by the motion of molten iron in a planet's core. The magnetic field acts as a shield, protecting the planet from the solar wind, a stream of charged particles that flows from the sun. Without a magnetic field, the solar wind can strip away a planet's atmosphere over time. Evidence of a past magnetic field. Studies of Martian meteorites have revealed that the planet had a magnetic field at least 4 billion years ago. This is based on the presence of magnetite crystals, which can only form in the presence of a magnetic field, that are found in some Martian meteorites. Impact craters. Scientists have also found evidence of a past magnetic field in the way that certain impact craters on Mars are shaped. Impact craters that were formed when Mars had a strong magnetic field have distinctive shapes that are different from those formed when the planet did not have a magnetic field. Evidence of remnant magnetic field. The Mars Atmosphere and Volatile Evolution or MAVEN mission has detected remnant magnetic fields in certain regions of the Martian crust, which suggest that the planet may still have pockets of magnetized rock that date back to when the planet had a stronger magnetic field. However, the exact history of Mars' magnetic field is not well understood, and there are still many questions about why the field became weaker over time. The loss of the magnetic field is one reason why Mars' atmosphere is now so thin, as it has been slowly stripped away by the solar wind over billions of years. Understanding the history and behavior of Mars' magnetic field is an important area of study for planetary scientists, as it can provide clues about the planet's geological and atmospheric evolution. Mars may have had microbial life. There is growing evidence to suggest that Mars may have had microbial life at some point in its history. Here are some key details. Presence of liquid water. As discussed earlier, there is evidence that Mars had liquid water on its surface in the past, and that some forms of liquid water may still exist on the planet today. Water is a crucial ingredient for life as we know it, and the presence of liquid water increases the chances of finding life on Mars. Organic molecules. Organic molecules, which are the building blocks of life, have been detected on Mars by several missions, including the Mars Curiosity rover and the Mars 2020 Perseverance rover. These organic molecules can be produced by both biological and non-biological processes, but their presence raises the possibility of past or present life on the planet. Methane. Methane gas has also been detected on Mars, and while it can be produced by non-biological processes, it is also a byproduct of certain microbial organisms on Earth. The presence of methane on Mars has led some scientists to speculate that it could be a sign of microbial life on the planet. Mars meteorites. As mentioned earlier, some meteorites from Mars that have fallen to Earth contain tiny structures that may be evidence of past microbial life. While this evidence is still controversial and subject to ongoing debate, it has added to the possibility of life on Mars. Overall, the evidence for past or present microbial life on Mars is still inconclusive, but there are many ongoing missions and research efforts aimed at finding more evidence. If microbial life does exist on Mars, it could be a crucial discovery that could help us understand the origins and evolution of life in the universe. In conclusion, based on scientific evidence gathered by space probes, rovers, and telescopes, scientists believe that Mars was a much different place in the past than it is today. Early Mars had a much thicker atmosphere, which would have allowed liquid water to flow on its surface and potentially supported a more Earth-like climate. Evidence of Martian meteorites suggests that Mars may have had microbial life in the past, making the planet an important target for future exploration.